Hi all, in this video we're going to teach you how to connect Google Colab to Google Drive. See covered. So the code to connect Google Colab to Google Drive is as follows. You want to go from google.colab import drive, that's on the first line. And then in the second line you want to go drive.mount and then content G drive forest remount equals true. The above code allows you to call files from your Google Drive account directly from your Python code. Now, the next thing we're going to teach you is how to import tools and packages from Python. So in this case, what you want to do is you want to import pandas as PD. So what pandas does is it allows you to work with like spreadsheets and tables in a really efficient way and manipulate data just as you would manipulate data in like Excel one spreadsheet. This allows you to manipulate like 10 or 20 or 30 or 50 spreadsheets all directly from Python. And so I'm going to show you that in a second. And then you want to import statsmodels.formula.api. You want to import NumPy, and you want to import matplotlib and pyplot. And the reason that you want to do this is you want basically the statistical tools and the numerical manipulation tools to be able to then run an analysis on your tables. Um, you also want to pip install Panda SQL. This will allow you to run SQL on the tables that you have in your data. Um, from datetime, import datetime. This allows you to have like correct dates. Um, and these are more statistical tools down here. Import math, import pandas, SQL, SPS, etc. So what you want to do is basically write this into one of the data blocks in your code and write this into one of the data blocks in your code along with this. So this should be your first data block. This should be like your second data block. And this should be like your third data block. Okay, so now the type of data that Python Pandas is excellent for. So let's say we have like some panel data, right? That has company data over time, right? So we have Coca-Cola in period T, Coca-Cola in period T minus one, Coca-Cola in period T minus two, dot, 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 and then Pepsi in period T, Pepsi in period T minus one, Pepsi in period T minus two, right? And let's say Coca-Cola is based in Atlanta, Georgia, Pepsi is based in Purchase, New York. Okay, so what we would do is, so this is like a one spreadsheet here, just this company's headquarters data, right? So Python Pandas would allow us to basically have this as a table, right? We could read this into Python Pandas as a table, and this would be one table. We then have a second table, let's say company largest customer. So let's say in each period for Coca-Cola, their largest customer is McDonald's. And let's say for each period, Pepsi's largest customer is Burger King, right? So we've got this table, which is like an Excel spreadsheet of basically the company's largest customers. This would be a second um, data set in Python Pandas, right? And so then we have this one company headquarters, this one company largest customer, and then we could have many more tables, right, about Coca-Cola. We could have who their largest vendors are. We could have, what states and cities all their stores are in, et cetera, et cetera. So you can imagine we could have like 10, 20 tables on McDonald's and on Coca-Cola, and then you with using Python Pandas, you can manipulate all these different tables to bring them all into one spreadsheet or bring them into a couple, and then it allows you to do the data manipulation. All right. Then once you have all this data using Python Pandas that you manipulated in Python Pandas, now you want to run some statistics, right? And so this is why the Python stats models are important, right? This is why we imported all these stats models here, right, in our code block 3 and to some extent in our code block 2. And the reason is, let's say we want to run a regression of return on earnings surprise, right? And so you guys know when companies release quarterly earnings, they analysts, come up with a consensus estimate for what the company's earnings are going to be. And then the company either beats the estimate and like makes more money than the analysts expected, or misses the estimate and makes less money than the analysts expected. So depending on what the earnings price is, right here it's a 1% earnings price, here it's a 2% earnings price. Depending on the size of the earnings surprise, typically you'll have a larger or smaller return, right, following the announcement. So here, if the company beat earnings, Coca-Cola beat earnings by 1% period T, then maybe the stock price, after that news was announced, returned to 3.5%, right? Or let's say it was 2% here, a 2% earnings price beat, then let's say the stock price return after that announcement was 4.7%. Right. So let's say you wanted to know on average how do returns behave following earnings surprises. You would then run a regression of return on earnings surprises. And if you guys are familiar with regression, it's basically on the y variable, you would have like the return. On the x variable, you would have the earnings surprise. And then typically you would have like a slope up, right? The bigger the earnings surprise, the bigger the return, or and then on the negative side, it would be the more negative it is, the more negative the earnings surprise, the more negative the return. So anyway, this stats package will help you run that analysis of how returns correlate with earnings surprises. And the Python pandas package, which we import here as import pandas as PD, this allows you to manipulate all the data. When you bring in the company headquarters data, the company largest customer data, the company earnings surprise data, the company return data, Python pandas allows you to bring all these spreadsheets together, so it's in a super organized one spreadsheet that's super organized like this, and then you can run the stats models. Anyway, so I hope you found this video helpful, and watch out for our next video on importing CSVs into Python.